Welcome to the preview video for the second evening with Jeff and Peter concerning model railway signalling. In this program we will discuss methods of making your signals work once you have finalised what you need to provide. There are many methods of actually having working signals, from relatively simple to as complex as you wish to make it. If you have a simple track arrangement, you don't need the equivalent of a major signalling centre to control it. There are many mechanical and electronic methods at your disposal and can provide ample scope for personal ingenuity. However, if you aren't entirely sure how to start, there are plenty of sources available to provide help and inspiration. Probably the easiest method of controlling signals is electrically or electronically. There are mechanical methods available, but they are rather prone to disturbance and not entirely practical for portable layouts. At the SR7mm Group, we use mechanically operated signals outside at Warrior Square, and there are a few others at Great Victoria Street and Southwark Goods. We have mechanically operated points at Warrior Square and in Southwark Goods Yard also. These are operated either from a lever frame based on the designs of Epsom and Ewell Model Railway Club and use a fairly extensive system of pulleys and fishing accessories, traces and weights to make them work, or they use brazing rod, various cranks and hand levers. This arrangement is more akin to the real thing and can be made to work very effectively, including bounce for the signals. It is particularly effective outside if the railway is exposed to the elements, as you don't need to protect electrical or electronic components from the weather. The drawbacks include a lack of portability and its susceptibility to disturbance and temperature variations once installed and set up. The more common modern method of operating signals is via the use of either solenoids and increasingly the use of servos. Dapol make a range of signals that are effective and are operated by their own mechanism, which could be described as a linear motor. As they come in a range of prototypes, these can be ideal for the modeller to add as a feature to their existing railway. On the SR7mm Group, we use servos for semaphore signals, but we take the operation a little bit further to reduce the complexity of the control panels. Originally, the different area control panels were effectively set up for manual cab control. You had to operate a switch to select which of two controllers had control over a particular stretch of line. So if you wished to cross over, you had to select both controllers to be the same. Warrior Square is the only location that still works like this. After operating experience, the arrangements were altered so that controllers were changed by relays associated with point operation rather than by switches. This reduced the driver workload and encouraged operators to set routes correctly. However, the control panels still had a multitude of isolating sections, the majority of which were rarely, if ever, used for their intended purpose. Fast forward to Plan Y, and a conscious decision was made to reduce the number of isolating sections on the control panels to those that were truly indispensable. This included making the action of signals at platform ends control the isolation of locomotives heading trains, and this is what we have done. It also follows on from that. If you are going to use the signals to isolate trains, it is necessary to try and get your signalling arranged to use interlocking. Now, I won't go into a full explanation of this, as there are plenty of sources available to help, but I will say that it effectively means that the correct route is set before you are allowed to clear a signal that applies to the route that it is set for. If the route is incorrect, you can't clear the signal. There are some very clever modelers, past and present, who have arranged this exactly as the prototype in its various forms, including full mechanical interlocking. This isn't practical for our purpose, as our line is considerably compressed, but it is entirely practical to simulate interlocking electronically, and this is what I have done. The vast majority of points are operated by tortoise point motors using a split plus and minus 10 volt power supply. The accessory switches are used for various functions via 4-pole changeover relays, and this is how we detect the position of the points. You select your route using the black point levers on the various lever frames, switching the plus and minus 10 volts. Once the route is set, you select your signals using the red or one of the few yellow levers. These act on micro switches which provide a 5 volt signal when closed to a Pickaxe microcontroller, which is an 8-bit computer on a chip. Now that has probably made everyone switch off this video, and I can hear the "all that is beyond me" comments as I write this. But let's consider this. All a computer is a series of switches. That's what it does. It makes decisions on ones and zeros, albeit pretty quickly depending on what you instruct it to do. You could use a simple switch for a simple application. I know modelers who use diode matrix for a similar purpose. The real advantage of how I implement it are capacity and physical size, and once you get into it, it isn't difficult to do. The difficulty increases proportional to complexity. I start with a spreadsheet. The one pictured is for Coulsdon C, and this is based on the operator's route setting crib sheet. Okay, again, it looks complex, but I have to consider that at this location we can have as many as 5 trains running at any one time. And remember, this isn't DCC. I need to know what movements will conflict with others. Once this is worked out, usually by the simple expedient of trial and error, I can start to write the interlocking program. Once this gets to a certain stage, I add the signals to the mix, with the added benefit that the interlocking controller or the servo driver controller can also drive isolation relays or other things. You set the appropriate route for your train, then the correct signal or signals for that route. The system checks what you have done is correct, with the added benefit of demanding that the system is actually worked. It was discovered that where this arrangement was not available, it allowed the operator to entirely ignore operating the signals if it was expedient. There isn't really much point spending time designing, making and fitting signals if they aren't going to be used once they have been installed. As soon as the signal lever is pulled, a command is sent to the appropriate servo driver, and this reacts to the instruction that it receives, including operating isolation relays if they are fitted. Even the colour light signals at Smithfield work in this manner, even though you don't need the added complexity of a servo driver for these. It just acts as a switch in this case. I have tried to make the system have the feel of the real thing. Of course, you don't need to make your own electronic components to achieve this. The reason we did it was mainly due to cost. If you don't want or need to make anything as complex as our system, there are ready-made systems available from Megapoints, for example, or self-assembly kits from Merg, amongst others. As for setting up the servos, I do this individually for each signal from a laptop, and it is necessary to have some form of strain relief in your operating mechanism. You don't need to spend a fortune on servos. The commonly available SG90 is our servo of choice and is more than adequate for the purpose. The high-level line from Smithfield to Coulsdon is fitted with colour light signalling. These signals are mainly operated by Heathcote electronics modules, which I have modified with more sensitive infrared detectors from block signalling, and with added interfaces to the manual levers at either end. As you can see from these references, there are traders available that can cater for your needs if you don't have the desire to make things yourself, and do not immediately discount items that are made for the smaller scales. Again, I have tried to make the signalling appear as prototypical as possible, but this is easier to achieve when you are just switching an LED on and off. Our railway is not DCC, but there are systems available for DCC that will achieve similar results. It is entirely possible to make signals work using JMRI, for example, and I use a DR4024 servo control module on my personal small layout, which can just as easily be used to operate signals as it is used to control points. That just about winds up how we at the SR7mm Group operate our signals. It appears to be complex, and it is to a certain extent, but what it does is it allows us to enjoy the viewing of the signals in operation. This considerably enhances the way the railway looks and the way the railway operates. I appreciate that not everyone has a system as large as ours, but I hope that in this illustrating how I have done things, I can encourage others to take the plunge in getting their signals to work and work as near as prototypically as possible. If you are going to take part in the program, please have your questions ready, and Jeff and I will do our best to answer them.